Hello.
Hi, Dr. Doudna. How are you?
Very well. It's very nice to meet you by Zoom.
Let me just start by congratulating you on being awarded the 2020 Nobel Prize in Chemistry. It's truly an astounding achievement, and you are all truly the ambassadors for science and U.S. values. I know, like many Swedes and Americans, are fascinated by CRISPR and the endless possibilities. So I guess the classic question is, where were you when the Nobel Committee called?
We're about 9 hours time shifted from Stockholm. So the call came in around, sometime after 1 a.m. in the morning here, California time. Unfortunately, I slept through the call, but I was awakened right before 3 a.m. by a reporter who was asking my opinion about the prize. And I said, "Oh my gosh, I just woke up. Who won it?" And she said, "Oh no, you haven't heard."
Oh, wow.
So I checked my phone, and of course, I had a number of messages from Stockholm, and it was, yeah, just as you probably can imagine, just incredibly exciting, surprising. I don't think any scientist could really ever predict something like that.
What motivated you to get started in science originally?
I loved math, and I was growing up in this very interesting kind of unique island environment. I found myself curious about plants and animals that had evolved to, live in Hawaii and had special properties as a result of their evolution in that island environment. Kind of very similar to what Charles Darwin had, you know, observed, in the previous century. And so I just found myself drawn to the chemistry of living systems, and I didn't really know at all how I would study that or what I would, how I would pursue it. And so I got very lucky that I had, a series of great teachers and mentors along the way who gave me opportunities and really encouraged my interest all along.
And how did you get from those early days to helping discover CRISPR?
In my graduate work, I was studying how, ultimately kind of the question of, how did life get started on the planet, and trying to ask that question or, answer that question in the laboratory with experiments that were exploring the way that information is encoded in cells. And eventually that actually led me to studying how bacteria use information from viruses to protect themselves from viral infection. And that was a process known as CRISPR. But in those days, back about 10 or 12 years ago, nobody understood how this CRISPR pathway worked. And that's where my lab and the lab of Emmanuel Charpentier collaborated to address that question.
What future potential of CRISPR are you most excited by?
I guess two things. One is the opportunity to cure genetic disease. I was talking to somebody earlier today who pointed out that something like 30 to 40% of hospital admits are people that suffered from a genetic disease. Equally exciting and important is that I think that CRISPR is going to be a major tool to help us deal with climate change and the issues that I think countries around the world are facing with this, because we have the ability to manipulate both plants and the microbes in soil precisely using CRISPR, so that we can do things like increase carbon capture. We can alter the properties of plants to give them the ability to survive in low water conditions like drought, as well as to protect plants from pests that are coming on, are more and more, sort of invasive because of the changing climate.
Incredible applications. I didn't even realize that was all possible. Are there any risks or worries you have about CRISPR being misused?
I've been pretty pleased, honestly, at the reaction of the international science community to this. I started working on kind of the ethics of CRISPR and sort of public discussion about some of these challenges back in 2015. And at that time, there was a lot less public awareness, certainly, about the technology. and few governments or regulatory agencies were aware of it. But it was already clear to me and some scientists that there was this very interesting challenge that we face, where we have this extraordinary technology in our hands that comes along with incredible responsibility.
Very, very insightful. Thank you. One of our embassy website viewers submitted a question. It's kind of a fun one, wanting to know whether CRISPR technology can be used to create superhumans.
Yeah, I get that question occasionally. And the thing that pops to mind is that there actually is a gene that has been targeted and changed using CRISPR in animals that increases muscle size. Guess what? Humans have a similar gene.
I heard there might be some application of CRISPR toward helping work on the COVID-19 pandemic, and that you might have actually been involved in that. Is there anything about that project you can share?
The most immediate application of CRISPR in the current pandemic is as a diagnostic. And it's an interesting application because it really does, it kind of goes back to the roots of CRISPR, because CRISPR, as I mentioned, it's a bacterial immune system, and bacteria use it to find and destroy viruses. And so the way that we and many others now are actually using CRISPR in the current pandemic is as a rapid detector of virus genetic material. I'll just say this, I'm incredibly grateful to the United States, I've been fortunate my whole career. I received a fellowship from the National Institutes of Health when I was in graduate school. I still remember, my parents were kind of horrified. I told them I want to go to grad school. And they were happy I was going to go to grad school, but they were like, oh my God, how much is that going to set us back? And we're going to have to go into debt and all this kind of stuff. And I said, actually, guess what? In science, the government pays. And they were shocked.
Nice.
But it's incredible. And that still happens. Yeah.
No, well, I appreciate you saying that. Well, really great hearing more about your story and CRISPR, and yeah, congratulations again. It's so exciting and really, really incredible. Incredible.
It's really fun to talk to you. I appreciate you reaching out.
Thank you again. Have a great week.
Happy holidays. Yeah.
All right. Bye.
Bye.